Welcome back. We're going to be talking today about Chapter 9, Section 4, the parabola. And we're going to build off of knowledge that we already have to start off with. We know that we already know from Algebra 2, Algebra 1, previous in the year in Precalculus, that the equation for a vertical parabola is y equals ax squared plus bx plus c, standard form quadratic. The opposite of that is the equation for a horizontal parabola is x equal to a y squared plus by plus c. So now if a is greater than 0, we know that the parabola opens to the right. And if a is less than 0, we know that the parabola opens to the left. Very common intuitive knowledge there. The x-intercept is now going to be c0, whereas with the vertical parabola, it was 0c for the y-intercept. And to find the y-intercept, we will set equal to 0 and solve. The axis of symmetry, instead of x being negative b over 2a, is now going to be y equal to negative b over 2a, because the axis of symmetry for a horizontal parabola will be a horizontal line. And the vertex will now be x negative b over 2a, just like with a vertical parabola, but switched. Just like our usual parabola equation, we can always use completing the square to put it in standard form. So let's go ahead and jump right into talking about the anatomy and the analytics of a parabola. So let's take a look first at the vertical parabola, and let's talk about different smaller pieces that we may not have discussed previously when talking about this conic section. So first of all, the focus will always be inside the parabola. And it will be p units from the vertex. It's important to understand that it's going to be p units from the vertex. From the vertex to the focus will be the value p, which you'll see pop up here when I show you the equation for the vertical parabola. The focal chord, we'll talk a little bit more about this as we get into the drawing of parabolas. But the focal chord has a total distance of the absolute value of 4p. And we'll talk a little bit more about that in a brief second. Last thing that you need to understand, word that you need to know before we talk about the definition of a parabola, is what a directrix is. And the directrix is always going to be outside the parabola. Always going to be outside of the parabola, and it's going to be p units from the vertex. Okay, so here we see a drawing of a parabola, a vertical parabola, and you can see that there's a vertex. We all know what a vertex of a parabola is, and there's the focus. Okay, and this imaginary line right here, it's actually invisible, is a line called the directrix. That's why it's labeled D. So the definition of a parabola is the set of all points whose distances from a fixed point, the focus, and a fixed line, the directrix, are equal. So whereas this point right here that we have drawn, D1, D sub 1, is exactly the same length as D sub 2. If I were to pick a different point, and maybe call this D sub 3, and go straight down to D sub 4, we would automatically know that D sub 3 is equal to D sub 4. Okay, obviously D sub 3 is a different length than D sub 1, but D sub 1 is the same as D sub 2, D sub 3 is the same as D sub 4. That would hold true for every single point on a parabola. So the equation of a vertical parabola is x minus h quantity squared. Notice that will give us a x squared term, which is equal to 4p times the quantity y minus k. notice that our y term will not be squared. Our focus is going to be at h, k plus p, the same x-coordinate as the vertex, but p units above the vertex. And the directrix will be at y equals k minus p, wherever that is. Okay, have the same y coordinate down 3, or I'm sorry, y value down 3. The axis of symmetry will be x equals h, and the vertex will obviously be at hk. Okay, and if p is positive, our parabola opens up, and if p is negative, our parabola opens down. So the same things are about going to hold true here. If you look at this picture here, a horizontal parabola is essentially a vertical parabola, only the x and y axis have been flipped. So the equation is going to end up being y minus k quantity squared. It's going to end up giving us a y squared value is equal to 4p x minus h. With the focus is going to be at h plus p, comma k, and the directrix is going to be a vertical line at x equals h minus p. It's going to be outside of the parabola. The axis of symmetry is going to be a horizontal line, y equals k, and the vertex, of course, is going to be at hk. And if p is a positive value, we're going to open to the right, and if p is a negative value, we're going to open to the left. So let's go ahead and dive right in. So right away we see we have an x squared term and no y squared, parabola. The fact that the x is squared, I know it's going to be a vertical parabola. There's no h and k, so I know my vertex is going to be at 0, 0. Now, right here, this 16y, x squared equal to 16y. If I start to go up here, I start to say, okay, well, there's my x squared term. There's my y term. That must mean that my 4p is equal to 16, meaning p is equal to 4. So I'm going to be able to go up 4 to find my focus and down 4 to draw my directrix. Perfect. Now if I want to draw my parabola to scale, I need to recall that the total distance of my focal chord, meaning the chord that's going through my focus and parallel to my directrix, okay, maybe we'll add that to our notes, parallel to directrix, is going to be 4 times p, okay, or 16. So that means I'm going to need to go 8 in each direction from my focus. 8 is right here, and 8 to the left is right here. Now I have a perfect upward opening parabola. And if you pick any point, let's just pick this point on the end of the focal chord. If you look at it right now, it is 8 units away from the focus, and it is exactly 8 units away from the directrix. So we know that that point is perfect and it lies on our parabola. So let's jump straight into the next one here. These examples will start to move a little bit quicker. Y squared, no x squared, so automatically I know I have a horizontal opening hyperbola, or I'm sorry, parabola, and I have a negative p-value, so I know it's going to be opening left. Okay, so my vertex is going to be at 0, 0 because my h and k are both 0. My negative 4 is equal to 4p, so p has to be equal to negative 1. That means my focus is going to be left 1 from my vertex. Very tight, you got to kind of zoom in to see it. My focal chord is going to be length, or absolute value of 4 times p, so it's going to be length 4. So since it's going to go parallel to my directrix, which will be p units away from my vertex, so 1 unit to the right, I know that my focal chord is going up and down. I'm going to be going up 2, down 2 for a total length of 4. And I can draw my horizontal opening left parabola. Okay, let's keep going and let's do some more examples. So here we go. X squared term, no y squared. Beautiful. I'm going to be dealing with a vertical parabola. Just going to, small step to put it in a standard form. I just need to slide my y term to the other side to make it negative 8y plus 2. And that means that negative 8 is equal to 4p, so p is equal to negative 2. Perfect. My vertex is going to be right 1, down 2. My focus will be down 2 from my vertex, so there's my focus. And my directrix will then be up 2 from my vertex, which is going to be right on the x-axis. So it's going to be hard to see. I'll try to draw it a little bit underneath, and I'll stick it out there. There we go. Okay, it's going to be right on the x-axis. My focal chord is going to be 4 times p, total length, which will be 8. So I'll be going to the right 4 and to the left 4. Now I can draw my parabola with great accuracy. Let's keep going. So here we go, another example. Beautiful. Vertical parabola. The y is squared, the x is not. Okay? We know we're going to be working, I'm sorry, I misspoke. The y is squared, the x is not. It's going to be a horizontal parabola. Perfect. Okay, my vertex is going to be right 5, down 3. Two is equal to 4p, so p is equal to 1/2. Very interesting. It's going to be tight quarters here, squeezing this in. But I know that I'm going to be opening to my right, so my focus is actually going to be 1/2 from my vertex to the right. Looks like one big dot, but it's not. I assure you that my focus is at 1, 2, 3, 4, 5 plus 1/2, so 5.5. It has the same y coordinate as the vertex, negative 2. Okay, my directrix is going to be half of a unit in the other direction. So let's get that drawn to the best of our ability here. Super tight quarters here, but it's a vertical line at x equals 4.5. And my focal chord will be 4 times 1/2, which is total length 2. So from the focus, I'm going to be going up 1, down 1, and there's our beautiful parabola. Okay, let's dive into some other examples here. So here we're given that our vertex is at 3, 2, and our focus is at 1, 2. So because the focus is always inside of the parabola, that tells us that our parabola is going to open to the left. Our p-value is going to be negative, okay, our negative 2, okay? So our equation is going to be that equation of a horizontal parabola, y minus 2 squared is equal to x minus 3. Now, we know that our p-value is 2, and right here is where we put 4p. 2 times 4 is 8. It has to be negative because we're opening to the left. So technically our p-value is negative 2. Let's make a special note of that. P is equal to negative 2. Perfect. So we know our directrix is going to be 2 units in the other direction. Of the vertex. And our focal chord will be 4 times 2, negative 2, which is 8. Okay, so we're going to be going up 4. The absolute value of 4 times negative 2 is equal to 8. And down 4. And we can draw our parabola. Okay, here's another one. Our vertex is at negative 2, 1. That's easy enough to draw. That'll help us with our HK. Our directrix is at y equals 2. Ooh, y equals 2, the equation of a horizontal line. Your parabola will always open away from the directrix. And if the directrix is 1 unit above the vertex, the focus is going to be 1 unit below. So we automatically know now our P is negative 1. Perfect. We have a vertical parabola. So we're going to have an x squared term. Is going to be x left 2, so x plus 2 quantity squared is equal to 4p. 4p, so negative 4, and then up 1, so y minus 1. Our focal chord is the absolute value of, has a total distance of the absolute value of 4 times p, so the absolute value of that would be 4, 2 in each direction from the focus, and there we go. A nice, happy parabola. Okay, 2 more. So we have our focus at 2, 2, and we have our directrix at x equals negative 2. Okay, so that's going to be a vertical line at negative 2. At negative 2. And we know that directly in the middle between our focus and our directrix is going to be our vertex. So our vertex has to be right here. It's real easy to see now that we're going to have an opening right parabola, because we always open away from the directrix and the focus always has to be inside. So that means that our p-value is 2. The distance from our vertex to our focus is 2. Our equation is going to be that of a y squared variety. So y up 2 will be y minus 2 quantity squared is equal to 4p is the value that we go in right here. So 8. And then our x, we're not shifting lateral in any direction. So it's just y minus 2 squared is equal to 8x. I need to draw it, sorry. Our focal chord has a total distance of the absolute value of 4 times p, which is 8. So we're going to be going up 4, down 4. We got ourselves a nice opening right horizontal parabola. And last one, our vertex is at 3, 1. And 2 zeros on the parabola with a vertical axis. Very interesting. If we have a vertical axis of symmetry, that tells us that we have a vertical parabola. So we automatically know that we are going to go x minus 3, we're going to shift right 3, equals 4p y up 1, which is y minus 1. Perfect. Now, we don't know where the focus is, we don't know where the directrix is, so it's a little hard to find p, but we do know that the point 2 zeros on the parabola, so we can just plug that in. So we plug 2 in for x, and 0 in for y. And if we do, 2 minus 3 is negative 1, squared is 1. This just becomes negative 4p. So p is equal to negative 1/4. So if p is equal to negative 1/4, our new equation is x minus 3 quantity squared is equal to 4p. So it goes right here. But 4 times negative 1/4 is negative 1. Times y minus 1. Perfect. So if p is negative 1/4, things get really tight. Our focus is directly underneath. I'll make a special note. The focus is at 3/4 because it's 1/4 underneath the vertex. And the directrix, it's going to be hard to see in my drawing, but the directrix It's going to be a horizontal line. It's going to be 1/4 above the vertex, so y equals 5/4. So I'll do my best to draw it here for you guys. I don't want to leave you disappointed, leave you with incomplete notes. The focal chord will be 4 times, the absolute value of 4 times p, which is 1. So we're going to be going to the right 1/2 and the left 1/2. Very tight parabola, very small. But thank you very much, and I hope this helps. I look forward to answering your questions.